Hi, welcome back to Math 263 and welcome to week 10 of the semester. And as you're maybe aware of, we're really now getting into the home stretch here where we're really close to the end of the topics here in Cal 3. I'm sure you're excited about it, and I know for sure my assistant here is very excited about it. Now, this week we're going to cover the rest of chapter 13, or the rest of the parts of chapter 13 we're going to see. We're going to skip section 13.6. So this week we're going to look at 13.3, 13.4, and 13.5. Now, in terms of course mechanics, this means we have three homework assignments, one for each of those three sections, and those are going to be on the Pearson MyLab Math as usual. There's no written homework this week, but there is, as is true in a typical week, we're going to have a discussion forum post due on Wednesday, and then a follow-up due this coming Sunday. Okay, so let's talk a little bit about what's in these sections. Like I mentioned in the previous intro video, this chapter 13, is very light on calculus, right? So this is a lot of preparation for doing calculus with vectors. So the next things we're going to look at for vectors are we're going to look at two kinds of product. So section 13.3 is going to be about something called the dot product or the scalar product. And that's going to take two vectors as an input, and then it's going to spit out a number as the output, hence the name of scalar product, though people usually call it the dot product. Notably, this book calls it the dot product. Now, the dot product measures something like length and something like angle. So what do I mean by that? If I take a vector and I dot it with itself, I get its length squared. That's the first key property. And the second key property is that if I have two vectors that are at right angles to each other, the dot product of the two of them is 0. So those are the two sort of fundamental geometric properties of this dot product that we're going to use over and over again. And we'll dig into that into more depth on Tuesday. The section 13.4 is going to have a different kind of product called the cross product. And the cross product only makes sense in space, so in 3 dimensions. And it's going to take as input two vectors and spit out a third vector. Now, secretly, the cross product is talking to you about planes. So that's the geometry I want you to have in the back of your head. If I give you two vectors, the two vectors are going to define for you a plane. So let me do that with these two fingers here. I have a plane defined by these two vectors. It's the plane that the two vectors sit inside of. And what the cross product is going to do is it's going to find us a third vector that is at right angles to both of my original vectors. And because of that, it's going to be a vector that's perpendicular to the plane that contains my two original vectors. And then, of course, there's a direction question. Does it go this way or does it go that way? And for that, we use something called the right-hand rule. And so the idea is that you take your 3 fingers like this from your right hand, and you put your thumb on the first vector, your index finger on the next vector, and then your middle finger points in the direction of the cross product of thumb with index. All right, so that's the right-hand rule, but you have to use your right hand for it. The other option, if you don't like contorting your fingers like this, is you can twist your fingers around like that. So you put your hand on the first vector and you curl them towards the second vector and the direction that your thumb goes on your right hand. is the direction of the result of the cross product of those two vectors. Okay, there are plenty of other videos and comics and things like that about the right-hand rule. I'll share some of those in Blackboard. And then finally, section 13.5 is about equations of lines and planes and the geometry of lines and planes in space and in the plane, notably in space. Okay, so we'll of course discuss all of this in much more detail on Zoom on Tuesday. I hope all of you come there, and I hope to see all of you. And I also hope all of you come on Thursday for our problem session. So there we'll work on some problems, and I think that'll be very helpful with the homework. So see you on Tuesday, hopefully see you on Thursday, and of course see you in the discussion forum and on Blackboard and by email and all the other ways we have of keeping